Hello students, this is Dr. Kirachekar. In this video, we are going to continue with the discussion on Prelims 2021 and the science and technology questions that have come in them. Okay, so because in the last session, we have focused on talking about the questions that have come from bio and biotechnology part, because if you remember, there were totally 11 questions and 5 of them from bio and biotechnology part. And the remaining questions came from chemistry and physics. 3 questions from chemistry part and 3 questions from the physics part have come. So let's begin our discussion with the chemistry questions that have come from the chemistry area. So the first question here asking about water can dissolve more substances than any other liquid. Water can dissolve more substances. They're asking about the ability of water to solubilize. Okay, because they normally say water as a universal solvent. So they're asking the reason behind why water is called so. The options are, it is dipolar in nature. Is it because of its dipolar nature, or it's a good conductor of heat, or it has high value of specific heat, and also whether it is its ability to form oxides of hydrogen. Which of these reasons are behind the solubility, universal solubility, almost universal solubility of water? Okay, to understand this question, this is very fundamental question. You need to understand the chemical nature of water molecule. To help you understand this, I have given you a chemical reaction here or interaction here. So what we are seeing here is water. Water is H2O, right? 2 hydrogens attached to an oxygen. And here I'm showing you another molecule called ethanol, alcohol, ethanol, ethyl alcohol we call, or ethanol we call. So look how water is reacting with it. Okay. So here, 2 things that you notice. One, hydrogen from the ethanol molecule is getting attracted to oxygen, forming this weak bond called hydrogen bond. We call this dotted line as hydrogen bond. Similarly, hydrogen attached to the oxygen being attracted to oxygen. So like that, this high electronegative atom, we call oxygen as electronegative atom with high electronegativity. It is attracting hydrogen towards it, because hydrogen usually positively charged, oxygen is slightly negatively charged. So what happens because of it, there's an attractive force that is building here, forming hydrogen bond. This attractive force is because of the dipolar nature. What happens here, because of shifting of charges, water shows slightly positive charge on one side, slightly negative charge on another side. So oxygen will carry negative charge, hydrogen will carry positive charges. So because of this distribution of charges leading to dipolar nature is resulting in this solubility. So water can react like this, form these bonds, hydrogen bonds, with many different type of substances, forming or solubilizing them. That is why we hear a famous phrase called like dissolves like. Hydrophilic substances dissolve in water. Hydrophobic, those that don't like water, it is dissolved in fats like substances or other hydrophobic substances. Okay, so the reason is dipolar nature. Option A is the right answer. Okay, next question. If you see, so this is about BPA, bisphenol A. BPA, a cause of concern in structural key component. It is a structural or a key component in the manufacture of which of the following kinds of plastic? So they've given 4 different plastics here. They're asking BPA is part of. So they're already telling it's a cause of concern, it's causing problems, and it is a key component of one of these. They're asking us to identify that. So LDPE, or low density polyethylene, first option, polycarbonate second, polyethylene terephthalate third, polyvinyl chloride is option D, or 4th option. LDPE, we normally see them in packages, see-through plastics like wraps, we call them, right? Wrapping around biscuits or etc. or condiments. Lids, plastic lids and toys contain this LDPE, which doesn't contain BPA. And polyethylene terephthalate, it is usually the disposable water bottles what we use. Okay, they are made up of this substance. And PVC pipes, I'm sure you all know of. PVC pipes are routinely used. Some types of PVC pipes use them, but they're asking should be a key component of this. So PVC occasionally use it. So not all PVC substances use them. So it is indeed used in polycarbonate. It is used in polycarbonate. What is polycarbonate? Polycarbonate is a hard type of plastic used in many consumer products for its strength, like beverage bottles, bottle like Coca-Cola bottles, etc. They tend to use them, and food containers, especially children's. Those feeding bottles, milk feeding bottles that are used, as you see in the image here, are made up of polycarbonate. And if you have really noticed on the bottles here, they say BPA free. They started saying it because it was shown that BPA can disturb our endocrine system, hormonal system, and reproductive system. And especially children seem to be sensitive to this, causing problems, even including cancer sometimes. So, Bureau of Indian Standards has banned this in children products. Okay, that is why this was in news multiple times. So, what they're asking is whether we are aware about its presence in substances or products made up of polycarbonate. Okay, as you see, the previous question was very fundamental question from the textbooks. You should be able to understand it. BPA, like things from regular know-how, from changes, and the bans that are happening on hazardous chemicals, we need to be aware about. So this is not outside the box question. This is what is expected in the UPSC exam. We need to have such type of knowledge. Okay, so in news like Down to Earth in 2019, we have seen an article like this: traces of banned bisphenol A found in baby bottles. So such articles would give you information related to this. Right, next. Triclosan. They asked about another chemical here. Triclosan, considered harmful when exposed to high levels for a long time. A long time exposure to this chemical seems to be harmful. Is most likely present in which of the following? Very similar question to the previous one. But here they're asking presence of triclosan and in what type of products do we normally find? So let's learn about triclosan. Triclosan stands for 2-hydroxy 2,4,4 trichloro-diphenyl ether. They're not asking this complex question of what is the chemical nature of it. They're asking where is it being used. So it is considered to be a lipophilic or lipophilic, however you say it, lipophilic compound. Lipophilic means lipid means fat, fat-loving compound. Meaning just like water-loving, hydrophilic, this is hydrophobic. So it reacts better with fat-like substances. And the most importantly, it has antimicrobial properties. Antimicrobial, meaning it kills microbes, microorganisms. So because of these antimicrobial products, it is used in personal care products such as toothpaste, antibacterial soaps, mouthwashes, etc. So which of those things that we are seeing in the options here? They are not food preservatives. Sodium benzoate, sodium propionate, those type of chemicals are normally used in food preservatives. They're not fruit ripening substances. Ethylene, carbides, etc. used in fruit ripening substances. Reused plastic containers, as we have just talked about in the previous question, they're not used. So they are used in toiletries. The right answer is the option D. Okay, that is about triclosan. Next question is another very fundamental question. Is with reference to street lighting, how do sodium lamps differ from LED lamps? A very expected question because LEDs have taken over, street lights, etc. So, and the previously used sodium lamps they are comparing with. So let's look into the statement. Sodium lamps produce light in 360 degrees. They produce light in 360 degrees, but it is not so in the case of LED lamps. So the angle of emission of light is it 360 in sodium lamps, but not true with LED lamps. As street lights, sodium lamps have no longer lifespan than LED lamps. So they're saying sodium lamps have longer lifespan. They're asking sodium lamps have longer lifespan. Is it true? Do they have better lifespan than LEDs? Question mark. I'll explain that. Statement 3. The spectrum of visible light from sodium lamps is almost monochromatic. While LED lamps offer significant color advantages. See, we have to understand that. They're not simply saying that sodium lamps is monochromatic, LED is not. They're not asking like that because there's a debate on that. Okay, sodium lamps are the monochromatic. How do we understand this? Okay, let me explain you so that you can make the decision on this and identify the right answer. So what do you see here? We're comparing LED with high pressure sodium lamps. Indeed, this is true that sodium lamps produce light in 360 degrees. If you see in the image here, you see lights actually illuminating surrounding areas in all 360 degrees. So they cover large area. But that is not the case with LED. LED produces 180 degrees. It only half plane, like if you see 180 degrees plane. So all this area is illuminated. So 180 degree illumination that we normally see with LEDs. So first statement is indeed right. Then lifespan, if you look into the lifespan, so an average high pressure lamps, here there is a mistake here. High pressure lamps have about 24,000 hours. Whereas LED lamps have more than 24,000 hours. That is 25,000 to 200,000 hours. So this is switched here. High pressure sodium lamps have a lifespan of about 24,000 hours. LEDs have about more than 25, almost 200,000 hours. So LEDs definitely have more lifespan than high pressure. So statement 2 is wrong. Then combination of wavelengths. If you see, high pressure sodium lamps use monochromatic. Mono means single wavelength light or single color light, like red or only blue, only yellow. They normally show yellowish. Right? So they are monochromatic. They produce yellow type of light. LEDs, there is a debate whether they are monochromatic or not. They say in individual level they are monochromatic, but we do have combinations of them. And that is why they carefully framed the last statement, as you see. The first one, I think you have understood, right? Sodium lamp produce 360 degrees, but not LED. Statement is right. Street light sodium lamps have longer lifespan, not correct. So statement 2 is not right. Statement 3, the spectrum of visible light from sodium lamps is almost monochromatic. That is true. But LED lamps offer significant color advantages. They have combinations of light. Sometimes they are monochromatic, but we have different combinations of colors that can be mixed to give rise to variety of colors. That is why LEDs do provide color advantage to us in street lighting process. So both 1 and 3 are correct, and always make sure that you are understanding the question. Sometimes they ask for a wrong statement. Here they're asking for correct answer using the code. So what are the right statements they're asking? So 1 and 3 are right statements. So this is option C is the right answer. Got it? So again, these type of things, this tells us what to learn when you are coming across things. Like LEDs, what should you compare it with? What type of information is needed? So they are guiding us towards that. Clearly, this is important. Follow this approach whenever you are learning about new things or things that are being shown in the newspapers. Okay, got it. Next. Which one of the following reason why astronomical distances are measured in light years? Why do we measure things in light years, especially those celestial distances between stars, between planets? Why do we use light years? Is it because distances among do not change, they are fixed? Are these things, planets, stars, etc., are they in fixed position? Gravity of stellar bodies does not change. Is it because of their gravitational force? Or is it because light travels in a straight line, no bending, not much bending at least? Or speed of light is same? What is it related to? Actually, most of you know it. So light years make measuring astronomical distances easy because they're huge. We cannot use kilometers. Then you have big numbers to describe them in. So light years are better because light travels so fast, covers larger distances. So it is better when we use it for those distances which are huge. Then planets in our solar system do not orbit in a perfect circle. They have different orbits. So distance is not always same. So you can clearly take out that distance among stellar bodies does change, is different from point to point. Okay, gravity does not play a big role here. So it is actually the speed of light. Light travels at the same speed. Because of that, we don't see much discrepancies in calculation. That is the reason why light is being used, because of its speed. This is, I think, most of you probably aware about. So not much explanation is needed. Then moving to the last question in this from physics. So in a pressure cooker, very simple concept, pressure cooker, but they ask slightly complicated things here. Many don't know the right answer to this. There are different opinions on what is the right answer. Okay, so I'll see what is logically right here. In a pressure cooker, the temperature at which the food is cooked depends mainly upon which of the following. What does it depend on? Okay, so area of the hole in the lid. There is a hole in the lid. Okay, on the lid area. Is that matters here? Or temperature of the flame, the input of the heat, weight of the lid, the heaviness of the lid. What is the right one? Indeed, if you see, I think there are many experts from these science and technology areas have expressed that all could be right. But let's look into it and what could be the possible answer to this. Area of the hole in the lid. If you see the pressure cooker, we actually have a lid and a safety valve, and there is a hole associated with that, right? So area of that, how wide it is, does it matter? Indeed, because in pressure cooker, steam builds up, right? And steam at certain point of time is too much. So to as a safety measure, they have given a safety valve so that extra pressure will be expelled. So it lifts up and extra pressure will go out. So the area of that is higher, we lose or more amount of steam can escape. So in that sense, as temperature depends on amount of steam, you may say that area of the hole in the lid also has a role. But does it true? Because they design in such a way that the hole is kind of area is kind of fixed. So it may not play a big role in real situations, but it has potential. So area of the hole in the lid can play a role. Temperature of the flame for sure, because the amount of heat is defined by the temperature of the flame. So this is definitely important. Third one is weight of the lid. So weight of the lid, again, it brings us the same problem like the statement one. So usually higher the weight of the lid or heavier the lid is, better it holds the steam. But provided if it's only lid that is dealing with it, only the weight of the lid that is dealing with it. But normally they have locking system, so which holds to the bottom portion, actually the bottom part of the pressure cooker. So in that sense, heaviness of the lid may not matter, but in theory, heavier the lid, better the pressure that is kept inside. Okay, so in the real life scenario where we have other means of holding it, in that case, if you consider that only 1 and 2 are correct, then option A is the right answer. Okay, but if you consider even weight of the lid, because if nothing else is holding it, then weight of lid only matters, and option D is the right answer. Yes, we do see some of these discrepancies or confusions being created in UPSC questions, but I think we have to go with the best guess and we have to wait for the actual key, what they say. To my knowledge, it is 1, 2 probably are right, considering how pressure cookers are designed. Okay, right. These are the type of questions that we have seen in the prelims. I hope they guide you. This explanation that I've given you here, analysis I've given you here, guides you to figure out how to prepare for the coming exams. Right. Thank you so much, guys. We'll meet you with new videos.